Welcome back to the Deep Dive. Today we're looking into the really extraordinary life of physicist Robert F. Bacher. And honestly, we're grappling with this contradiction that seems, almost impossible on the surface. I mean, how does someone start their career mapping out the incredibly precise wavelengths of light from atoms, spectral measured down to the angstrom? And then how does that same person become the chief experimental physicist, the choreographer, really, for the nuclear implosion, the most demanding, violent technological event we've ever created? It feels like a massive jump, doesn't it? From reading light colors to shaping this world-ending shockwave. But the sources we looked at suggest Bacher's whole life was actually this single-focused journey, understanding and manipulating structured motion. He saw the same fundamental rules at play, whether tiny atoms or massive machines.
That's really the core insight from these sources, yeah. They view Bacher's work through this specific lens they call motion theory. So our mission today, our deep dive, is to trace that common thread. Bacher's exceptional mastery of synchronization. He applied the same basic method reading phase, enforcing coherence to everything, whether it was the standing waves inside an electron shell or, timing 32 high explosive detonators perfectly, or even, surprisingly, getting a post-war committee organized. Same underlying logic.
Okay, before we dive into Bacher's actual timeline, we really need to get a handle on the language here. This motion theory framework, it uses some pretty abstract terms. Could you maybe quickly define the three key ones we'll need and maybe tie them to something physical right away?
Yeah, absolutely. Let's ground these. So first up is identity. In this context, identity is basically defined as a long-lived standing wave. Or you could just think of it as a system's stable spectrum.
Oh, okay. So if I'm Bacher looking at an atom, its identity is the specific pattern of light it gives off, its fingerprint.
Exactly that. It's the stable, characteristic pattern of motion that defines the system.
Right.
Second, time. Now, time here isn't treated like some universal clock ticking away. It's the measurement of movement across the motion. It's the rate. Bacher's work was all about rates, wasn't it? How fast things change, how quickly energy leaks out.
All right. Rate is key.
And third, maybe the most important one for today, synchronization density. This is framed as the crucial state variable. It describes how strongly a system converges toward its most organized, lowest leak path. The sources even draw a parallel to gravity, suggesting this density pulls a system together, organizationally speaking.
Whoa, hang on. So this idea is synchronization density. Does that mean the implosion Bacher worked on, the successful one, was essentially like creating a temporary, super intense gravitational field, but manufactured to force the core together?
That is precisely the interpretation offered by the theory, yes. The core was compelled by this overwhelming, perfectly timed pressure. It forces it to find its most compact, its most organized state. And that state naturally minimizes leakage and maximizes the intended effect, physics as perfect rhythm.
Okay.
Yeah.
That's a powerful image, makes it concrete. So let's rewind. Bacher's beginnings. Spectroscopy. He was instrumental in turning those, beautiful but messy lists of colored spectral lines into actual engineering data.
Yep.
So in these empty terms, what is a spectral line, and how did knowing them give Bacher control?
Right. So a line, fundamentally, it's a piece of information about the system's internal structure. In this motion theory view, a line is a permitted reconfiguration of the system's standing wave pattern. Think of it less as just a color and more as a specific, allowed way the system can vibrate or oscillate, a harmonic mode. And by collecting enough of these lines, enough of these allowed harmonics, Bacher could work backwards. He could deduce the system's exact underlying structure, its geometry and stiffness, as the source puts it. This established his core method, really, know a system by its spectrum, and then use that deep knowledge to predict how it will behave and ultimately to steer it.
So know the spectrum, know the identity, and therefore know the engineering possibilities and limits. Okay, this implies then that pretty much all technology, whether it's a simple circuit or, a complex resonant cavity, it's essentially about editing spectra. Is that the idea?
That's exactly the idea. You're building hardware filters, resonators, lenses to intentionally shape the natural, often chaotic motion that's already there. You're allowing only certain modes, certain frequencies and rates, the ones you want to synchronize. You're sculpting motion. You're basically ensuring your machine's identity matches your design specs precisely.
Okay, that makes sense. And that concept takes us neatly from those, relatively roomy electron loops to the next phase of his work, the incredibly dense, high-stress world of the atomic nucleus. What's the big change when motion gets confined like that, inside the nucleus?
Well, everything gets way more intense, faster, louder, more crowded. The motion is just severely restricted. In the MT language, high confinement jacks up the retuning pressure. The system is constantly being forced to change its state, and it dramatically shortens the coherence time. The system can't hold a stable pattern for long at all. It's like, imagine taking a beautifully tuned guitar string and then trying to play it inside a tiny, rattling metal box while shaking it. The clear note just gets lost immediately. It's unstable.
And the sort of classical physics result of this, which Bacher studied a lot, are those really broad energy widths of nuclear resonances, right? Measured in MeV, millions of electron volts, very fuzzy states.
Exactly. And the source materials have a great term for these broad resonances. They just call them leak meters.
Leaf meters.
Yeah. If you picture the particle's standing wave, that broad width means the loop just can't hold its phase. It's leaking energy and coherence out into its surroundings super quickly, like trying to make a tuning fork out of, I don't know, damp clay.
I see.
It might vibrate for a microsecond, but it just loses its shape and tune instantly.
That's a really good analogy. Okay, so things are leaky and unstable. Bacher and his generation needed ways to probe this environment, maybe even stabilize it. Which brings us to neutrons. No charge, right? So they're perfect probes. They go in, bounce around, and tell you how the nuclear environment responds, how it retunes.
Right. And this led them to master the technique of moderation. This is absolutely crucial. Moderation in the MT framing is about intentionally boosting the synchronization density. You're trying to get the incoming neutron, which is usually fast and erratic, to synchronize its motion with the slow, orderly, rhythmic motion of the atoms in the moderator material, like graphite or heavy water.
So it's not just about slowing the neutrons down, which is the usual explanation. It's about making them more disciplined, putting them in sync with their environment.
Precisely. You're trading the neutron's chaotic kinetic energy for the thermal discipline of the lattice. You take this wild particle and force it into lockstep with the moderator, and that controlled synchronization is what allows for controlled capture events later. The neutron is now behaving predictably enough that when it hits a target nucleus, its interaction reliably prints the spectrum of the target in the form of emitted gamma rays. You can finally read the target's identity clearly because the probe itself is behaving.
Wow. So, okay, Bacher's mastering coherence at the smallest scales, reading spectra, managing leaks, enforcing discipline using this synchronization density idea. Now for the huge leap, Los Alamos. How do you get a 5-foot sphere of high explosive to act with the same coherence as one tiny tuned nucleus?
This is where it all comes together on the biggest stage, right, at Los Alamos. And the source material reframes the whole implosion problem, the gadget, in a really interesting way. It wasn't fundamentally about brute force, it was a timing problem, an existential timing problem.
Really, I always pictured it as just needing unbelievable crushing power.
Well, the potential energy, the force, was there in the explosives, but raw power is useless if it arrives unevenly. Implosion, in this view, is pure synchronization engineering. It's the incredibly precise, timed retuning of that solid sphere of explosive so that every single point on its surface starts moving inward at the exact same instant.
I see.
Any jitter, any asymmetry, even minuscule, and the converging shockwave becomes unstable. The core doesn't compress uniformly, it squishes unevenly, and you get, well, not much, a fizzle. Bacher's job, heading the experimental physics division, was essentially to prove they could achieve and measure that phase alignment.
Okay, let's break down the parts then using this synchronization lens. Start with the detonators.
Right. The detonators, they are the absolute phase sources, the starting gun for the whole event. Any timing difference, any jitter in their firing, we're talking nanoseconds here, introduces an initial asymmetry that ripples through and destroys the whole process.
Okay, phase sources. Then the explosive lenses, they look weird, with different explosives shaped together.
They function as motion gradient shapers.
Motion gradient shapers. Can you unpack that a bit? Is that like a super fancy, highly engineered fuse?
In essence, yes, but extremely sophisticated. They're carefully shaped charges using explosives with different detonation velocities. Their job is to take the initially outward expanding spherical wave from each detonator point and perfectly reshape it, bending it into a converging, perfectly symmetrical inward moving shockwave. They ensure the motion gradient, the rate of compression, is identical everywhere as the wave travels inward.
Got it. Shaping the wave front. And then the diagnostics. Things like the Rala experiments with that radioactive source or the pin contactors.
Those were Bacher's eyes and ears. They were his tools for confirming the identity of the implosion process while it was happening. Rala, pin arrays. These weren't measuring the final yield. They were designed purely to measure if that critical phase alignment, that simultaneity, was actually holding across the whole sphere as it compressed. They were alignment detectors.
So the real success wasn't just did it go bang, but was the motion clean?
Exactly. Success was defined by the clean remapping of motion, taking the initial, stable, solid lattice structure of the explosives in the tamper and transforming it smoothly and symmetrically into a tiny, dense, compressed core, a new nucleus-dominated identity. There's a great quote in the source summarizing Bacher's relentless focus here. Implosion is timing, not temper. The quality of the synchronized movement was everything.
Yeah, that's a mind-bending level of control. Okay, final big shift. After the war, Bacher moves into administration, policy, things like the Atomic Energy Commission. He applies the same thinking. Read the patterns, tune the system to organizations. How does synchronization theory possibly apply to managing people?
Well, the sources describe institutions like labs, commissions, government agencies as very complex coupling graphs. Think of them as networks. And these networks have their own spectra. They have characteristic modes of behavior. Some are stable and productive, like, say, a reliable budget approval process. Others are unstable and damaging, like bureaucratic infighting, security leaks, or runaway projects. Bacher was a huge advocate for civilian oversight of nuclear programs, right? He helped set up the AEC. In the MT language used by our sources, this kind of oversight is about deliberately adding damping to unstable modes.
Damping, like putting brakes on certain behavior.
Exactly. You're introducing regulatory friction, checks and balances, to slow down or suppress those fast, potentially chaotic modes driven by secrecy or unchecked ambition. The goal is to increase the coherence time of public trust. You're effectively editing the organization's spectrum, reinforcing the stable, trustworthy modes, and damping down the dangerous, leaky ones.
That implies a kind of scientific detachment applied to human systems, which fits with that quote you mentioned earlier, the one linking the two worlds.
Oh yeah, the one-liner really captures his perspective, doesn't it? It's something like, if you can phase align 32 detonators, you can phase align a committee. Just replace PETN with coffee and promises.
Okay, that's good. It shows the same underlying belief in structured control. And it speaks to his personality too, right? People described him as completely unflappable. The steady hand.
He had to be. He was the system's master oscillator, as one source put it. Think about the incredible tension during those implosion tests or the political battles after the war. When everything around him was jittery, losing phase, full of noise, someone needs to hold a steady reference signal, a reliable beat that everyone else can lock onto. Bacher played that role. Not flashy, maybe, but absolutely essential for keeping the whole system synchronized and functional.
So looking back at his legacy, what really stands out is this absolute insistence on empirical grounding. The rule he lived by: don't trust any theory unless you can connect it directly to a measurable detector response.
Right. And this is where the motion theory framework tries to anchor itself firmly in Bacher's practice. A concept like synchronization density only has meaning if it demonstrably leads to a lawful pattern in something you can actually measure.
So you need to see it show up in the data somehow.
Precisely. It has to cash out as a measurable change in a spectrum, or a shift in a correlation function between signals, or a tightening of a timing curve. If you can't point to the data, if you can't measure the rate change, the theory is just hand-waving.
He operated in a world where rates determine outcomes. Trigger timing precision, camera shutter speeds, neutron lifetimes, reaction rates. It all loops back to that core MT definition. Time is the measurement of movement. It is the rate.
Absolutely. His major successes weren't just about discovering new particles or forces. They were victories of imposing rigorous rate discipline over inherent noise, leakage, and jitter. He took concepts that can sound almost philosophical: identity, time, coherence, and turned them into hard engineering specifications. Specs that decided whether a bomb worked or a committee reached a decision.
Okay, so wrapping this up. Robert Bacher's career, seen through this lens, shows this incredibly powerful unified approach. First, you meticulously read the patterns of a system, its spectrum, its modes. Then you systematically tune those patterns to achieve the coherence you need. He showed the principles are the same, really, whether you're dealing with an atom, a complex machine, or even a group of people.
It's a striking generalization, isn't it? And if this motion theory perspective is right, that synchronization density is the key variable controlling how systems organize themselves, well, it makes some testable predictions. For example, the theory suggests that in many systems you shouldn't expect performance to improve gradually as you reduce noise or jitter. Instead, you should see a sudden jump, a sharp S-curve transition. The system might stay messy and unreliable for a long time, but then once the phase jitter drops below some critical threshold, boom, it snaps into highly coherent, reliable performance.
That's fascinating. So performance isn't linear. It can suddenly lock in once things are quiet enough.
Exactly. Which leads to a final thought for you, the listener, to maybe chew on. It builds directly on Bacher's core principle, spectral ID as identity test. If, as these sources propose, identity equals spectrum. Consider this. Motion theory predicts that even tiny, subtle, microstructural changes in materials under stress wave, before you see any crack or obvious failure, should show up first as minute but detectable changes in their spectrum. Maybe trace isotope spectra or acoustic spectra. So here's the thought. If your own identity, professional or personal, starts to drift under pressure or stress, what spectral changes, what subtle shifts in your usual reliable patterns of behavior or thought might you expect to see first? What are the early warning signs in your spectrum?